All right, my friends, let's take a look at problem 51 on section 9.1. The directions say find the center, foci, and vertices of the hyperbola and sketch its graph using asymptotes as an aid. So I can definitely see why someone's asking about this one. So we've got x squared minus 9y squared plus 2x minus 54y minus 80 equals 0. Challenge number 1, copy the problem down correctly. Hopefully I've done that. And then, just like usual, we'll group the x terms, complete the square with those. I'll leave that off for a second. Let's group the y terms. I'm going to factor out that negative 9. And then I'm going to move the 80 over to the other side. So magic ingredient for the x's would be 1. So I'll add 1 to balance that onto the other side. Magic ingredient for the y terms would be 9. So I just subtracted 81, so I'll subtract 81 on the other side. And this is where this problem gets weird. So for the x's, we now have the quantity x plus 1 squared minus 9. And then for the y's, we have y plus 3 squared. And what's weird about this is we get 0 on that side, so there's no way to get this in the typical standard form for a hyperbola. So what we're going to find here is that we're not really going to get much of a hyperbola at all. We're just going to get 2 intersecting lines. And so to see that, I'm going to add this y expression over to the other side. So and then let's square root both sides, not forgetting plus or minus on one of the sides. So okay, so really what I'm going to do is manipulate this in the next step to make it look like point slope form of a line. So the point slope form is y minus y1 equals slope times x minus x1. And I realize that this is so insulting for me to tell you this. I'm just pointing out that the slope needs to be on the x side. And currently you can see your coefficient is on the y side. So I'm just going to divide both sides by plus or minus 3. So then I'd have y plus 3 by itself, and I'd have plus or minus 1/3 times the quantity x plus 1. And then hopefully I'll remember to tell you a mildly funny story that goes with this problem in a little bit. So anyway, so I can tell that this graph hits the point -1, -3. Whoa. And then I can tell that the slope of one of the lines is positive 1/3 and the slope of the other line is negative 1/3. So up 1 to the right 1, 2, 3. So here's one of the lines. So maybe I'll go down 1 and to the left 1, 2, 3. Just have a little more to aim for. Okay, so here's one of the lines. And then the other line hits the same point but has a slope of negative 1/3. So down 1 to the right 1, 2, 3, and then up 1 to the left 1, 2, 3. Okay. So in the back of the book, if you look, they call this a degenerate hyperbola, which I prefer to call it 2 intersecting lines. And then the mildly funny story that goes with this problem is this was years ago, and one of my students had asked another student about this problem, and I didn't hear the whole conversation. I just heard a little piece of it, which is kind of dangerous when you're a teacher. And I thought I heard one of my students call the other student a degenerate, like as if because you asked this question, you must be a degenerate. And I was horrified and kind of called that student out, was like, oh, how could you say that? And it came out that really he was just saying that it's a degenerate hyperbola, and he was just using vocabulary that I had never heard, math vocabulary that I had never heard before. And it was a little embarrassing for me and for him because I called him out when he didn't really deserve it. And Anyway, it was a little bit of a mess, but I now know that when you get a 0 here, instead of something that you can turn into a 1, that these two intersecting lines, a fancy name for that is that it's a degenerate hyperbola. So anyway, be careful where you're throwing that terminology around and everything should be okay. All right, I hope this makes sense. Take care, everybody.